Now we're going to look at quicksort. Now quicksort is actually an algorithm which probably looks really familiar. You probably are thinking, wow, this looks a lot like insertion sort. And if you're wondering that, then the answer is yes, it does. However, it's a very different algorithm. Now just to recap, if I was doing insertion sorts on this list, what I'm doing is taking out the 9 and then sorting the rest of the list. Now this is going to be O of n squared because I'm essentially sorting everything else and then finding the place that the 9 goes into. Now quicksort is very different. What quicksort does is essentially says, okay, I have the 9. What I'm going to do is split the list into two different lists. Let me get everything in this remaining elements, so everything in here, which is less than 9. So in this case, it would be the 3, 7, 3, 1, 5, and 8, and 0. And then everything that's greater than 9, and basically sort those things. So the list of everything which is less than 9, then the list of everything which is greater than 9, I quicksort this, I quicksort this, and then I throw the 9 in the middle. And this will essentially sort it. And it turns out that quicksort, in the worst case, is actually O of n squared, because it's almost like insertion sort. However, it's kind of more random because we're betting that everything less than 9 is going to be half the list, and everything greater than 9 is going to be half the list. So then we actually get a nice n log n on average. Now, I'm not going to go into an actual proof of why this is n log n, but at a high level, you should understand how this is different than insertion sort, because we're essentially sorting the left half and sorting the right half, and then putting it in the middle. We're not sorting the entire thing and then coming up with the left and coming up with the right. So if I write this out, quicksort of L, we know that the base case is going to be when the length of the list is less than 2. I just return L. Otherwise, now I basically need to say, okay, the first is equal to L of 0, the rest is equal to L of 1 onwards. Now, everything lower is all the elements, so for lm in rest, if lm is less than the first element, that's the lower stuff. The higher stuff is equal to the lm's for lm in rest, if the element is greater than the first element, and we'll also say equal to. Now all I have to do is quicksort the lowers, add in the first element, and then quicksort the highs. And this will give me the answer. Because essentially, we're saying, okay, partition the list into everything lower and everything higher, sort the lowers, put the first element in, then sort the highers. And now if I try this, and it did not print anything because I didn't say to print, if I try this, I get the sorted list. And so this is really awesome because now we've sorted this list so many times, and at every single time it's the same thing. So this is quicksort.